matrices, and in session 1 we'll be mainly concentrating on to see what is a matrix. We'll try to define a matrix and we'll try to define some of the terms related to matrices. And we'll also see different types of matrices. We'll study about some of the standard types of matrices, and as we proceed with the learning of matrices, we'll come across some other more types of matrices. And as an algebra of matrices, we'll also learn about what do we mean by equality in matrices. So let's try to learn first how do we define a matrix. A rectangular arrangement of numbers which are real or complex is called a matrix. Now, if you remember a set A which has a collection of 1, 2, 3, 4, 5, 6. There are 6 elements in this set. Now, in a set, the order of the elements is not important, but the element should be non-repeated. Then we have defined a set A. Now, the same set A, these elements, if they are represented in, say, let us say we arrange them as 1, 3, 5 and 2, 4 and 6 and put them inside an arrangement of square brackets. Then these 6 elements of the set A are now arranged in 2 rows and 3 columns. Such an arrangement of numbers is called a matrix. Now, what is the main difference that you observe between a set and a matrix? First, in a matrix, the position of the element is also fixed. It belongs to which row and which column is been fixed in a matrix. But in a simple collection of set, the order of the elements is immaterial. Now, the same arrangement of 6 numbers can also be done in the form 1, 2, 3, 4, 5 and 6. Then this is a matrix in which there are 3 rows and 2 columns, which is different from that of this arrangement. Now again, these two matrices are different from 1, 2, 3, 4, 5 and 6. This is again different from that of this, though both are having same 2 rows and 3 columns. But the position of the element, here the number 2 is present at the first row, second column. But here the number 2 is present at second row, first column, right? So once the number position changes, this matrix would be different from that of this matrix. So as an example, the arrangement of numbers which could be real or complex. So we can also say another example of a matrix having real and complex entries is say 3 plus I, 1 minus 2I, 3, 4, 0, 1 plus I, 2 minus I and 4. If you look at this, the entries are, few of them are real numbers and few of them are complex numbers. Such an arrangement of elements in terms of rows and columns is called a matrix. Now, how do we denote this matrix? Yes, as the position of an element is fixed in a matrix, the matrix is denoted by square bracket of Aij, where m cross n, m is denotes the number of rows and n denotes the number of columns. Then Aij with m cross nth order, where however this I and j, I runs from 1 to m and j runs from 1 to n. Such an arrangement is a simple notation for a matrix. So if you write it in expanded form, say we are talking about a matrix A which is having 4 by 3 order. That means there should be 4 rows and 3 columns. Then how will be the element here? It would be A in the first row, in the first column, right? Similarly, how will be the element placed at this position? It would be first row, second column. And like this, how many columns should be there? There should be 3 such columns. That means A1, 3. Similarly, how will be the element at this place? Can we have one more column here? No, because another element comes here. Then the number of columns will also become 4. Wherein j values should run only from 1 to 3 according to this. Then the next element would come here, which is in the second row but the first column, and then A second row, second column, A second row, third column. Similarly, A third row, first column, A third row, second column, A in a third row, third column, A fourth row, first column, fourth row, second column, A fourth row, third column. Then this will be the notation of the matrix in the expanded form. This will be in short denoted as Aij. How are this I and J ordered? Yes, they are of the matrix elements of a matrix of order 4 by 3, where how will be the values of I? Yes, I would be from 1 to 4. Look at them. I values are 1, 2, 3 and 4. I values keeps changing from 1 to 4. And how are the column numbers changing? Yes, the column numbers are 1, 2 and 3. So the J which denotes the column entry is running from 1 to 3, right? So if we come across a matrix A which is given by Bij of order 3 by 2, then how will be the expanded form of this matrix? Yes, that should be a matrix having 3 rows and 2 columns. So there should be 3 rows in the matrix and 2 columns in the matrix. That means 3 horizontal arrangements and 2 vertical arrangements. Then how will be the elements? Here I would be running from 1 to 3 and the values of J would be from 1 to 2. So let us take each of the case. We'll have B11, B12. Can we have the next entry? No, because the column numbers has to be maximum 2. Then B21, B22. Similarly B31 and B32. This would be the expanded form of this matrix, right? Now based on the row number and the column number, let's define some simple types of matrix. A row matrix, as the name itself suggests, a matrix which has only one row is called as a row matrix. That means if the matrix A is such that it is having Aij of order m by n. If the number of rows, that is m, is 1, then such a matrix is called a row matrix. So how will be the general form of a row matrix? It would be A1j of order 1 by n, where I value is fixed to be 1, but the values of j can be from 1 to n, which if we expand, the number would be A11, A12, A13, A14. Only one row exists, but there are n columns. So there will be A1n would be the last element. Such an arrangement of elements in a single row, such a matrix is called as a row matrix. Can we write an example of a row matrix? Let us see. When we express A as a matrix having 1, 3, 5, 7. Is that a row matrix? Yes. What is the order of this matrix? Clearly it is having one row and 4 vertical columns. So the order is 1 by 4. So do we have a row matrix? As the number of rows is only 1, this clearly represents a row matrix. Now similar to that of the row matrix, now we have a matrix which has only one column. Such a matrix is called as column matrix. So a matrix A which is in the general form as Aij, where order is of m by 1. So that what will happen? The value of j is fixed to be 1, but I, the row number, would in 1 to m. Then such a matrix is called as column matrix because it has only one column. So how will be the entries in these elements? Yes, as it will have only one column, the elements would be A11, A21, A31, A41, so on up to how many rows are there? There are n such rows. So A, M1, this kind of a matrix which has only one column is called a column matrix. Now can we attempt to write an example of a column matrix? Yes. As an example, we can consider a matrix A which has -2, 4, 0, 1. Is it having only one column? How many rows are there? There are 1, 2, 3, 4. There are 4 rows. So what is the order of this matrix? Yes, 4 rows into one column. So that one, where only one column is there, hence this is an example of a column matrix. Now another simple type of a matrix, that is square matrix. A matrix with the number of rows and the number of columns equal is said to be a square matrix. When we have a matrix A which is having entries Aij of order m by n, if m is equal to n, then the matrix is called a square matrix. The name square itself suggests the number of rows must be equal to the number of columns. Then such a matrix is called square matrix. That means in general, when we have a matrix of Aij of order m by m, then I runs from 1 to m as well as j also takes all values from 1 to m, then such an arrangement is always a square matrix. Sometimes such a square matrix is also denoted by A, M. No need of writing m cross m. When we write AM, it says it's a square matrix having both rows and columns equal to M. Now when we attempt to write an example of say 2 by 2 square matrix, that means number of rows should be 2 and the number of columns should be 2. Let us say 3, 4, 1 and minus 2. How many rows are there? Number of rows is 2. How many columns are there? The number of columns is also 2. As these two are equal, can we say this is a square matrix? Yes, this is a square matrix of order 2 by 2. Now can we write a square matrix of order 3 by 3? Let us try. There should be 3 rows and 3 columns. That means total 9 elements should be arranged in this array. So let us check 1, 0, 5, 4, minus 1, 3, 2, 4, 1. How many rows are there? There are 3 rows and 3 columns. Such an arrangement is an arrangement of 3 by 3 where the number of rows is 3 and the number of columns is also 3. Such a matrix is a square matrix. As the number of rows is equal to the number of columns, the matrix name is, it's a square matrix. Now what happens if the number of rows and number of columns are not equal? Yes, we get a rectangular matrix. A matrix with the number of rows and the number of columns unequal is said to be a rectangular matrix. So a matrix A, which is general form as Aij of order m by n, where m is not equal to n, is said to be a rectangular matrix. The number of rows and the number of columns should be unequal. How would be an example of an rectangular matrix? Let us write 3, minus 1, 4, 4, 2, minus 5. What is the order of this matrix? Yes, there are 2 rows and 3 columns, 2 by 3, whereas the number of rows is 2 and the number of columns are 3. As the number of rows and number of columns are not equal, this is a rectangular matrix. 1, 4, 5, 3. Is this a rectangular matrix? Yes, this is having 4 rows and 1 column, right? Then the number of rows being 4, which is not equal to the number of columns, which is only 1. Therefore, this is also an example of a rectangular matrix. Now, what is a null matrix? Yes, as the name suggests, a null matrix is that matrix in which all the elements are zeros. That is, Aij equal to 0 for all I and j. Then such a matrix is called null matrix. Say when we are talking about A of order 3 by 2 is a null matrix. Then how will be the elements of this? Yes, there will be 3 rows and 2 columns and all the entries, there should be 3 rows and 2 columns and every entry in this must be 0. So how will be the matrix? The matrix in which all the entries are zeros. This is a 0 matrix of order 3 by 2. How will be a null matrix of order 2 by 2? Yes, there should be 2 rows and 2 columns and all the entries of this 2 by 2 matrix must be 0. Then the null matrix of order 2 by 2 would be in the form 0, 0, 0 and 0. So if every element of a matrix is 0, then such a matrix is called a null matrix.